to the intake path, and the injectors add fuel to form the mixture. Compression stroke again. Both valves are closed, and the piston rises to squeeze the air-fuel charge to about 1/10 of its volume. That higher pressure and heat set up a fast, complete burn on the next stroke. Power stroke again. The spark fires just before top dead center, combustion pushes the piston down, and that's the only stroke that actually makes torque. The spark sequence you see tracks the firing order. Exhaust stroke. The exhaust valve opens, and as the piston rises, it pushes the spent gases out into the manifold, past the upstream oxygen sensor. Then the cycle repeats from intake. Sure, we can walk through that with a visual step-by-step on the twin. Forward radar is up first. It sits behind the grille and sends out millimeter-wave pulses, then measures the echoes to figure out distance and closing speed for objects ahead. It does this rapidly and works in many weather conditions. Ready for the next step? The camera? Camera step now. The windshield camera picks up what radar can't, like lane lines, shapes of vehicles, pedestrians, and signs. Its wide view overlaps the radar, so potential hazards are cross-checked 2 different ways. Blind spots and close quarters coverage now. Corner radars watch the areas the mirrors miss and warn about traffic coming from behind, while ultrasonic sensors handle the last few feet at low speed for parking and obstacle detection. Fusion is the decision stage. The radar and camera data get merged into one track of objects. If both agree a collision is likely, and the driver hasn't reacted, it escalates to pre-charge, warns the driver, and then applies braking through the ABS modulator. Verdict. The air filter box is flagged as a fault. The strongest evidence is the active fuel delivery related code P2635, which points to a fuel system issue rather than the air filter itself. Live readings look plausible at idle, with about 601 RPM, throttle around 21%, and barometric pressure at 99 kilopascals, so nothing there screams bad airflow. There is also a Bank 2 Sensor 1 O2 monitor item noted as unknown with a 12% margin. So treat that as low confidence supporting data until we resolve what that test actually represents. Let me walk through what this panel is telling us and highlight the key faults. Verdict: the evap vent valve is in a fault state. The strongest evidence is the evap related codes P0449 and P0455, and the evap readiness is not ready, which means the system hasn't completed its checks yet. There's also a Mode 6.0 note, Bank 1 Sensor 1 O2 monitor failed with 0% margin, while Bank 1 Sensor 2 passed, also with 0% margin, so that's right on the line and worth treating cautiously. Finally, a separate sensor node flags the upstream O2 on Bank 2 as suspect at about 0.8 volts with a flatlined behavior, suggesting a potential sensor or circuit issue to verify separately. Sure. Let's walk through how fuel injection works using a simple visual sequence. First up is the lift pump. The in-tank electric pump pushes fuel through the feed line at supply pressure, and in a returnless setup, the regulator on the tank module sends excess fuel back into the tank. That keeps the supply steady before it heads to the high-pressure side. Ready for the next step, the high-pressure pump? High-pressure pump step. A cam-driven direct injection pump ramps the fuel to over 100 bar and feeds both rails so the injectors have the pressure they need. Injection step now. The injectors spray a precisely measured mist directly into each cylinder, and that pulsing you see is the injector pulse width. That timing is the ECM's main control for how much fuel gets delivered. Closed-loop pressure control now. The rail pressure sensor feeds back to the ECM, and the ECM trims the high-pressure pump so actual rail pressure matches the target. That keeps fueling stable as load and RPM change.